This law has been called the greatest generalization achieved by the human mind. And you can get already from my introduction, I'm more interested not so much in the human mind as in the marvel of nature who can obey such an elegant and simple law as this law of gravitation. So our main concentration will not be on how clever we are to have found it all out, but on how clever she is to pay attention to it. Now, what is this law of gravitation that we're going to talk about? The law is that two bodies or bodies exert a force upon each other, which is inversely as the square of the distance between them and varies directly as the product of their masses. And mathematically, we can write that great law down in the formula, some kind of a constant times the product of the two masses divided by the square of the distance. Now, if I add the remark that a body reacts to a force by accelerating or by changing its velocity every second to an extent inversely as its mass. It reacts, it changes velocity more if the mass is lower and so on, inversely as the mass. Then I have said everything about the law of gravitation that needs to be said. Everything else is a consequence, a mathematical consequence of those two things that I said. That's a remarkable enough phenomenon in itself that the next lecture will consider this in more detail. Now, I know you're not all here. I know some of you are, but you're not all mathematicians, and so you cannot all immediately see all of the consequences of these two remarks. And so what I would like to do in this lecture is to briefly tell you the story of the discovery, tell you what some of the consequences are, what the effect of this discovery had on the history of science, what kinds of mysteries such a law entails, something about the refinements made by Einstein, and possibly the relation to other laws of physics. The history of the thing, briefly, is this, that the ancients first observed the way the planets seemed to move about in the sky and concluded that they all went around, along with the Earth, went around the sun. This discovery was later made independently by Copernicus after they had forgotten that, people had forgotten that it had already been made. Now, the next question that came up to study was exactly how do they go around the sun? That is, exactly what kind of motion? Do they go with the sun at the center of a circle, or do they go in some other kind of a curve? How fast do they move, and so on? And this discovery took a longer to make. The times after Copernicus were times in which there were great debates about whether the planets in fact went around the sun along with the Earth, or whether the Earth was at the center of the universe, and so on. And there were considerable arguments about this. When a man named Tycho Brahe got an idea